The nutrition label is the opportunity for a consumer to understand what really is in the product. That food label becomes the place where they can evaluate products and see how those foods really do fit into these recommendations that we're promoting.
This is the most significant change that we've seen in food labeling for the last 20 plus years.
And Carbohydrate in its new and revised format gives you more information, I think. It gives you your total. It now separates your sugars inherent from added sugar, as well as fiber. So I think it's just providing more information for people to make an informed decision.
On behalf of the Abbott Nutrition Health Institute, welcome to Decoding the New Nutrition Facts Label, Carbohydrates, which will outline the mandated changes manufacturers must make to food labels in the United States by January 2020. This program will focus on carbohydrates, featuring Beth Johnson, Principal and CEO of Food Directions LLC in Washington, D.C., where she helps clients gain valuable insight into the U.S. Department of Agriculture, the Food and Drug Administration, and the Centers for Disease Control and Prevention. She was also formerly the Acting Undersecretary for Food Safety at USDA. Dr. Christopher Taylor, an Associate Professor of Medical Dietetics at The Ohio State University in Columbus, Ohio. Dr. Taylor has spent 16 years exploring how lifestyle factors impact obesity and chronic diseases. He also currently serves on the editorial board for the Journal of Nutrition Education and Behavior. And Dr. Carrie Ryan, the Director of Science and Innovation at Abbott Nutrition in Columbus, Ohio.
I'm going to talk to you about decoding the new nutrition label, focusing on carbohydrates. As a disclosure, this educational event is supported by Abbott Nutrition Health Institute, Abbott Nutrition. On this slide, you can see that we've got objectives specifically focusing right now on recognizing the significant changes to the nutrition facts panel. So we're going to go into some details about how carbohydrates have changed on the label. First, we're going to start with an overview of the nutrition facts label itself. Prior to 1990, most packaged foods did not have nutrition information. In 1990, Congress passed the Nutrition Labeling and Education Act, giving FDA the authority to require nutrition information on most packaged foods. Before we start talking about what changes have been made and why they were made to the nutrition facts panel in the most recent rule, published in 2016, we're going to talk about the impact of what those changes have on manufacturers, healthcare practitioners, and consumers. For manufacturers, they're facing questions about whether or not to reformulate a product to meet new recommendations or to meet expectations of consumers. They're looking at whether or not nutrient content claims have changed or potentially gone away because of the changes relative to the recommendations and the requirements on the label. Serving sizes have changed for particular foods. About 25 items have changed serving sizes, and we also have some new serving sizes for foods that weren't around in 1990. And then also because of the focus on certain ingredients and certain nutrients, we may see changes to ingredients. Manufacturers are going to have to look to see what they want to do and if they want to change the ingredients they're currently using. For healthcare practitioners, menu nutrient calculations, dietary analysis, meal planning is all going to change as the updates to the labels change. That information that is currently in those systems is going to have to update to reflect new daily values, new nutrients, and new ways to calculate the information that's in there. And for consumers, they may see different labels which may impact their purchasing decisions. So why is the label changing now? Well, we certainly want to see a refreshed design. It's been over 20 years since the label has changed. We've got updated science, and again, we better understand how consumers use the label. Specifically for total carbohydrates, as you can see on the label that is on the right, we now have dietary fiber, total sugars, including added sugars. The total sugars has changed. It used to be referred to as just sugars, and then the added sugars line has been added with a daily value. Manufacturers have been given 2 years to update the labels. And that may seem like a reasonable amount of time, but when you really understand all the complications, the complexities, and the decisions that are going to have to be made along the way, it does go very, very fast. Information has to be updated and calculated on dietary fiber, total sugars, and added sugars. There's no way through a chemical analysis to distinguish between added sugars and naturally occurring sugars, so that information is going to have to be kept in records, calculated using ingredient information from suppliers, and that's all going to take time. But you can see the information on carbohydrates is much more complex than it was in the past, but the hope is that with that additional information, consumers will be able to more easily put together a healthy diet. There are some exemptions, as you can see on the slide, for this particular update to the Nutrition Facts panel. Foods sold for immediate consumption, foods with insignificant amounts of nutrients, infant formula, medical foods, which have a very specific definition, and bulk foods for further manufacturing do not have to update the Nutrition Facts panel. This slide shows the complexity of the interactions between the effects of the label and the actual changes themselves. I've talked a lot about putting added sugars on the Nutrition Facts panel. So why were they added? Well, certainly, as most of you are probably familiar with, there's been a lot of attention by expert groups to decrease the amount of added sugars in the diet. Public health groups, such as the American Heart Association and others, have suggested and recommended lowering the amount of added sugars. The 2015 Dietary Guideline Committee report for the first time put a very specific recommendation in about how much added sugars to consume, and they limited the added sugar consumption to 10% of the total daily calories. And that ended up in the actual dietary guidelines for Americans for the first time. How are added sugars defined? Simply put, added sugars are defined as anything added to a product that exceeds its natural sweetness. So if it is not naturally occurring, or it is not concentrated to 100% of the sweetness that is naturally there, it's counted as an added sugar. It doesn't matter what form that comes in, including juice concentrates. But added sugars do not include fruit or fruit juice concentrated from 100% juices sold at retail packs. So if that is the level that is naturally occurring in that fruit juice, adding anything up to that amount is not going to be considered added sugar. Currently, you're going to see added sugars in a number of different forms, but what is added during processing may include syrups, honey, molasses, high fructose corn syrup, maple syrup. So let's delve in a little bit more to the debate about added sugars. The public health goal is very clear: reduce consumption of added sugars. And consumers are paying attention to that, and they're looking for claims about no added sugar. Naturally occurring sugar and added sugars, though, the science tells us, can't be differentiated in how the body uses them. So even though they're distinguished on the labels, our body doesn't make a difference. And there's no analytical way to differentiate between the naturally occurring and the added sugars. So in addition to the added sugar line, we also have a new daily value for carbohydrates. The former daily value for carbohydrates was 300 grams. That's now decreased to 275 grams. Why do we see that change? It's the 300 grams was calculated on a 60% of the 2,000 calorie diet. So 2,000 calorie diet is pretty much what we all use in order for recommendations and to make sure that the nutrition information on the label is consistent. At that point, fat accounted for 30% and protein accounted for 10%. Because of the focus on the types of fats as opposed to the total fat intake, the recommendation has changed for fat from 30 to 35%. With that increase in fats, we have to decrease either protein or carbohydrates. So protein is at 10%. The science doesn't tell us that we need to decrease that, but given the fact that some of the carbohydrates are from added sugars and other types of more simple carbohydrates, then the science does say that we can decrease the amount of carbohydrates from 60 to 55% of our total diet. That gets us to the 275 grams. So The DV for the total carbohydrates is more than double, though, and this is important, it's more than double the RDA for adults 19 years of age and older. And that is, again, because when we look at what we need versus what we can consume in our diets and create a healthy diet, there is going to be some differentiation between the RDA and the daily value. Now we're going to look at how to calculate the percent daily value for carbohydrates. We all know that carbohydrates have 4 calories per gram. In this particular product, there are 37 grams of carbohydrate. Now, knowing that the daily value is 275 grams, it's been updated to 275, you divide 37 grams by 275 grams, and you can figure out the daily value. So it's 13% of the daily value, 13% of the amount of carbohydrate you should consume in a given day. Now, this slide is to help understand how many decisions and the types of decisions that manufacturers are facing right now as they move toward updating the label. One thing is to make sure that we understand clearly what added sugars are, and to make sure that manufacturers need to make sure they account for all of the added sugar that may be in the product. They need to get that information largely from the suppliers. Some of it they may be adding themselves, but some of it is going to be in the supply that they're getting to put into the final product. They need to look and see whether or not those ingredients, how they're added, and as in bakery products, if it's used in fermentation or that type of product, you're not going to see the sugar, the added sugar in the end product. You're going to see it added to the beginning, but it's not going to be the end product. So how that's going to be defined on the label and how that's going to be calculated is still yet to be determined or at least provided by FDA. That information is going to be crucial to make sure that the label is accurate when it comes to sugars. Additionally, when it comes to calculating, as I mentioned, manufacturers are relying on suppliers to give them that information, but they can analyze for total sugars. So when they calculate for the added sugars and the naturally occurring sugars, if that number doesn't match what they have analyzed for total sugars, there's a problem. And they're going to have to go back and through very detailed analysis, talk to the suppliers, talk to individuals to find out what's missing. That, again, is going to take time. It's complex, and it's going to be very, very detailed but crucial to get right. And then as that information gets determined, there may be some changes to claims that they want to change, and then they're going to have to update the design of the label because there's new information, there are new lines on the label, so all of that's going to have to be done. And especially in this instance with added sugars, making sure that your records are accurate and very detailed are going to be absolutely crucial in case FDA comes in to make sure that the added sugar information on your label is accurate. So what are consumers going to see, and what changes are they going to see on the label? Well, sugars, what is currently on the label now says sugars, as you can see on this slide, is going to change to total sugars. And then underneath that line, as you can see on the second graph there, it says includes, in this case, 10 grams of added sugars with the daily value of 20%. There's currently no daily value for total sugars, nor is there a daily value in the new label for total sugars, but there is for added sugars. So concern over confusion is significant. Making sure that consumers understand that the added sugars is a part of the total sugars and not additive is going to be essential. Also making sure that they look at the label in totality. It's not alone the added sugar line that's going to say whether or not the product is healthy. And then also with changing health and nutrient content claims. Certain nutrient content claims like healthy, for instance, today don't have added sugar as part of the definition, but as we look forward and more attention gets placed on added sugar, it's now on the label, there's a very good chance that we may see added sugar becoming part of other nutrient content claims and limiting the use of nutrient content claims depending on the amount of added sugar. So in conclusion, how can we help consumers and also our patients? Certainly educating on how to read the label is essential. For the average healthy American, looking at the entire label is absolutely key. Not focusing on one particular nutrient, but looking at whether or not the carbohydrate level is in balance with the protein and fat, what you've had during the day, what you might be able to include for that particular meal or that particular food item. You want to look at the whole label. Moderation is key. That hasn't changed. I think that will continue to go as we move forward. Calories in, calories out, balancing exercise with the amount of food that you eat. That's absolutely essential to a healthy diet and a healthy lifestyle. And then understanding label claims. Label claims can be very confusing. And so taking it upon yourself to really do some research and understand what particular label claims mean can help your patients, your clients, and others extensively as they're trying to understand how to use the information on the food package when they're putting together a healthy diet. So why? What next? When are we going to see some of these changes? Certainly, the science has evolved. We know more today than we did in 1990. Also, how consumers use the label. So making sure that the label reflects that is another good reason why the label was changed. And then you're going to see changes happen maybe sooner rather than later, but certainly we're going to see an evolving marketplace. Some products are going to be updated within the next few months. Other products are going to take at least until July of 2018 and maybe even longer. So be looking for it, be ready, and be ready to start educating.
In this module, I'm going to discuss carbohydrates and the importance carbohydrates play in metabolism in the body. I have 4 objectives for this presentation. The first is to identify the classification of carbohydrates. The second is to review digestion, absorption, and transport. The third is how we use carbohydrate as a fuel source. And the fourth is how we regulate blood glucose and how that's related to type 2 diabetes. So carbohydrates, by their name, are hydrated carbon, so water added to carbon molecules. There are organic compounds that are a varying number of monosaccharides or individual sugars. They provide us 4 calories per gram. And our estimated needs for meeting the needs for 50% of the population is 100 grams a day. And meeting the needs of 95% of the population of the RDA is 130 grams. We have several different types of carbohydrates that are classified into simple carbohydrates, complex carbohydrates, and then we also have high fructose corn syrup. Simple carbohydrates are made of the subunits, so single monosaccharides, so individual glucose, fructose, or galactose, and disaccharides, which will be 2 monosaccharides together. Our complex carbohydrates are longer strings of carbohydrates, and they'll be in oligosaccharides or polysaccharides like starch and glycogen. Additionally, there is high fructose corn syrup, which is made from cornstarch. It has a higher fructose content, and it's commonly used in sweetened food and beverage products. There are 2 different storage forms of glucose. The plant version of storage for glucose would be starches, and there are 2 different types of plant starch. There's amylose, which is a long, straight chain of glucose molecules, and then amylopectin is a long, straight chain that also has branching of glucose from that central strain. So the animal storage form of glucose is glycogen. About 2/3 of the glycogen that we have in our body is stored in our liver, and 1/3 of it is stored in our skeletal muscles. This storage form of glucose can last us for approximately 24 hours. So the glucose stored in our muscles can be used to fuel our activity, and our liver serves as our storage form of glucose that can be released into the blood vessels to fuel our tissues. Carbohydrate digestion begins in the mouth, and salivary amylase is produced by the salivary glands, and it is used to start breaking down those long chains of glucose or carbohydrates, those polysaccharides, and starts breaking them down into the shorter dextrins that you see at the bottom of the screen. And as you can see on the right, amylopectin is the branch chain of carbohydrates, but the salivary amylase breaks the carbon chain across along the long string where the branches remain intact during this process. Once the carbohydrate moves into the stomach, the high acidic environment of the stomach will deactivate that salivary amylase, and that will stop the digestion of those long polysaccharide chains. So once carbohydrates move into the small intestine, there's a much more favorable environment for the digestion to take place. Pancreatic amylase will be emptied into the small intestine, and that will then begin the digestion of those long, straight dextrin chains that we have from amylase and start breaking those down into disaccharide components, so two sugars together. And then those branch chains that we have from the amylopectin will break down those into maltose, or those two sugar components, as well as maltose with the branch chains attached. Now, once we've obtained those two sugar compounds, the disaccharides, the digestion will occur at the brush border to break those two sugars down into their individual subcomponents. So lactase will be used to break the lactose sugar down into a glucose and a lactose. And then for those branch chains, isomaltase is needed to actually break those limit dextrins down to attack that branching point and break those down into individual glucose subunits. So now that we have digested those long polysaccharides down into their individual monosaccharide units, it doesn't matter what the primary source was of those. The ultimate endpoint are those individual monosaccharides that are going to be absorbed. So what you'll see on the left is a sodium-dependent absorption process from the small intestine into the enterocyte. And then fructose has its own separate pathway that you'll see on the right, which is a facilitated diffusion transporter that will move that fructose from the small intestine into the cell. The process of absorption for glucose and galactose require sodium and a sodium gradient. So that sodium gradient is maintained, as you see at the bottom left, with a sodium-potassium pump that requires energy. So the absorption of glucose and galactose actually require energy. And then finally, once all of those monosaccharides have been pulled into the cell, those are then passed through the basolateral membrane into the capillaries to be passed off to the liver through the GLUT2 transporter. So now that the monosaccharides have been absorbed by the body and sent to the liver will process them and get them ready for the body to utilize. So the liver can convert galactose and fructose, the two other monosaccharides, into glucose for the body to use. That glucose can then be used as the carbon skeleton for various aspects of metabolism. It can be used to convert into ribose so that we can create DNA and RNA. And it can also be used for many other molecules throughout the body. As well, the liver serves as our storage form for carbohydrate. So we can take that glucose in, put it on the shelves in glycogen, but once our glycogen storage becomes full, once those shelves get stocked, we have to then utilize that glucose in a different manner, which can be converted to fat and sent off for storage, or it can be released into the bloodstream for the body to utilize. So glucose is the preferred fuel source for the body, and it is primarily necessary for the actions of nervous tissue and red blood cells. So glucose serves a very important fueling need for the body. And when glucose is lacking, we need to find ways to cover that loss of a fuel source. One of the ways that we can do that is through gluconeogenesis, which is to create glucose from other compounds, which might be amino acids or fatty acids. But when that isn't possible or enough, we can go through ketogenesis, which is to create ketones to serve as an alternative fuel source. Those ketones are created from the inefficient breakdown of fatty acids. And ketosis, in extreme conditions of lack of glucose, in the early stages can help prevent muscle breakdown, so it can be somewhat preventative. But in a long-term state, it actually facilitates muscle breakdown because of that continued need that we're not able to meet without glucose. One of the other important aspects of carbohydrate is glucose serves as essentially a currency for a lot of different aspects within the body. So glucose will then be broken down through glycolysis into 2-pyruvate. So we start with a 6-carbon glucose, becomes a 3-carbon pyruvate. But that pyruvate now, based on metabolic need, could be converted to alanine and be used to make amino acids. It can be converted to acetyl-CoA to create fatty acids. It can be converted to oxaloacetate, which is then used in the Krebs cycle and electron transport to generate energy. And when we're exercising really hard in an aerobic environment, That will then be converted to lactic acid, which is an inefficient use of carbohydrate for energy, but then can be later utilized and restored to create glucose. As well, in times of need of glucose, we can convert back to glucose from pyruvate. So carbohydrate is stored in the liver as glycogen, and then it will be released into the blood so that it can fuel tissues and facilitate the metabolic activities that carbohydrates support. The blood glucose needs to be regulated so that we can maintain a healthy environment for our cells. Our pancreas serves as the thermostat for our blood glucose levels. So when blood glucose levels begin to rise, the pancreatic beta cells will release insulin, and that insulin will then stimulate the cells to take that glucose back up, and it'll slow the liver's release of glycogen out into the bloodstream. And then when our blood glucose levels begin to drop, the pancreatic alpha cells are going to release glucagon, and glucagon is going to have the opposite effect of insulin, where it's going to stimulate the liver to break down glycogen and send that glucose out into the bloodstream. So one of the most common chronic diseases we have linked to carbohydrate intake and carbohydrate metabolism is type 2 diabetes. And type 2 diabetes is most commonly a function of insulin insensitivity at the cells. So insulin serves as the radio waves, and the cells have an antenna that is used to pick up the insulin and catch that signal to bring in the blood glucose. And with type 2 diabetes, we have essentially an inefficiency of those antennae to pick up the signal to say, bring in the glucose. So when that happens, blood glucose continues to circulate, and those blood glucose levels begin to rise. And our thermostat is kicking on, and it's releasing insulin. So we're putting more insulin out into the system, and it increases the chance that it hits the antenna, but there's still a problem with our reception. So our status of type 2 diabetes, we see this rise in blood glucose or hyperglycemia, but now we also see this rise in hyperinsulinemia. So our mechanisms to address type 2 diabetes really need to be targeted at moderating carbohydrate intake as well as increasing insulin sensitivity. So these take us back to many of our aspects of metabolism that mean the type of carbohydrate that's absorbed or consumed, how quickly it's digested, how quickly it gets into the bloodstream, and then how well we're able to regulate that glucose is going to be very important to our metabolic functions.
I'm going to talk to you today about the physiology and the food science of carbohydrates, with particular emphasis on how they play in oral nutrition supplements. So one of your key objectives for this talk today is that you will understand the role and the food science of carbohydrates in oral nutrition supplements, otherwise known as ONS. So I want to start today with some of the basics. As health professionals, we know that carbohydrates play a key role in nutrition and that they provide energy. Also, we know that it is the preferred source of fuel in the body. The brain, red blood cells, muscle all use glucose, which we know is derived from carbohydrate, as that preferred fuel source over, say, the carbohydrate derived from fat or protein. It's also important for this talk today for me to tell you about the fact that quality and quantity of carbohydrate is very important. It can and should be modified not only for preference, but for metabolic conditions that we are looking to manage. So continuing with some of our basics here, I want to talk about the taste for carbohydrates. I think we all can agree that we love carbohydrates, whether it's a big bowl of pasta or a sweet treat. And that taste for sweet has probably developed very early, and maybe even be from an evolutionary standpoint, to drive our intake of nutritious foods. Our first taste of sweet is often breast milk. But even through childhood and then adulthood, there is a general, and I would say universal, preference for sweetness as a taste compared to bitter or sour. And if you look across the globe in any culture, there will be a preference and a liking for sweet. I want to also talk too now about some of the food science of carbohydrates. This list here, or these examples, are not comprehensive or exhaustive, but I wanted to give you some idea of the role that carbohydrates play that you may or may not actually taste. The first is that of the example of rheology, or more simply put, viscosity. Carbohydrates can contribute to the viscosity of a product. I think a simple explanation of that or example would be adding starch to a liquid, which, as we all know, forms a gel. So pudding might be an example in that category of creating viscosity with carbohydrate. Also, there are sugars, mainly your monosaccharides like glucose and fructose, that are considered reducing sugars. They can react with amino acids in a reaction called the Maillard-Browning reaction. And this is what gives foods not only a new flavor or taste, but it also creates the browning. So in this example, you see is bread being toasted, creating not only the brown and the toasted elements of texture, but also new flavors. You also have this Maillard reaction in things like the searing of meat, which is again the same reaction happening. Now finally then, we talk about sweetness and its role in flavor. Yes, it delivers the sweet taste we all know and love, but it can also be used to mask or accentuate other flavors in products. So why is this important? Well, like I just said, it supports the flavor of an overall product, whether it's intensely sweet or less so. It can balance out flavors. Even in products that don't necessarily taste very sweet, there might be levels of sweetness or sweeteners added to bring that balance in. And what you see here in the green chart on the right are intensity levels, if you will, or an index for sweetness, where sucrose, which is a disaccharide, is sort of our standard for sweetness intensity. And other sweeteners, whether it be monosaccharides that have been listed here or other sweeteners, are kind of judged against that. So fructose on this chart you'll see is slightly more intense in its sweetness than sucrose, whereas other monosaccharides are less so. And again, it is a worldwide preference for sweet. So palatability and taste are very important, whether we're talking about just social engagement or, in this case, of metabolic conditions being managed. Taste is still a very important factor. And now that we know that everyone loves sweet and sugar and carbohydrate, I want to talk a little bit about the types of carbohydrates that you will see in foods and ONS. And we start with the basics here, is sugar versus sucrose. As I had mentioned previously, sucrose is our sort of standard index for preferred sweetness, and it is a disaccharide, and it's your everyday granulated table sugar. Other examples would be that of glucose or fructose, these being monosaccharides. Both of them are sugar. All these sources are sugar, and they do contribute to both the overall sweetness of a product as well as the functionality of the product, referring back to some of the examples from the previous slide. Now I want to show you with the labeling element the kinds of carbohydrates you might typically see on an ingredient panel. So what you see here are starches, examples being for cornstarch, tapioca starch. Maltodextrins are also quite common and can often be from tapioca or corn. And maltodextrins serve as bulkers or thickeners in most products, and you'll see them across the spectrum of food categories. Corn syrup and corn syrup solids as well. I want to note, though, this special carbohydrate section here. First, what you see here are some examples of fibersol, isomaltulose, but you also see different types of fibers as well, soy, oat, and even celluloses, all that would classify as fiber. And finally, there are emulsifiers and stabilizers that you might be familiar with, such as carrageenan and gellan gums and Arabic gums, etc. So these would all appear on an ingredient line, and they would all either be reported as a sugar, an added sugar, or a starch within the context of the Nutrition Facts panel. Now I want to talk a little bit more about each one of them, just so you can understand the role and the chemistry here. So first we start with maltodextrin, and this is a starch that's simply produced by some partial hydrolysis. And again, this is a fairly easy and simple source of energy. It's fairly quickly digested and absorbed. And like I said, it's very commonly used in many food products, given its utility and its functionality in the texture, the mouthfeel, and the bulking and thickening of many products. And fibersol is another type of carbohydrate you might see on an ingredient panel. This is actually a modified maltodextrin, and it becomes, in essence, a soluble fiber. And so it is more slowly digested, and therefore it's a low glycemic carbohydrate, meaning it will minimize or lower a postprandial glucose spike. And also, when fibrosol is digested, the portions that reach the lower colon can also be fermented, creating short-chain fatty acids. And finally, sucralmalt. Again, this is another low glycemic carbohydrate, but this would actually be labeled as a sugar. And however, because it's been modified, it is more slowly digested, and again, it can minimize a postprandial glucose spike. So it's a nice carbohydrate to use with other carbohydrates if you're looking to manage blood glucose. And in this slide, what you see is a demonstration of how various carbohydrates can impact blood glucose. In this case, what you're seeing is the effect of a blend of carbohydrates on postprandial glucose tolerance test. And you can see that by combining low glycemic carbohydrates and fiber, you can minimize or lower that postprandial glucose spike compared to other carbohydrates. So now I'd like to talk about how we consider carbohydrates when making an oral nutrition supplement to manage a particular metabolic condition. So I have some examples in this chart here to go through. The first would be chronic obstructive pulmonary disease, also known as COPD. In this case, we're talking about carbohydrate avoidance. We would want to develop a lower carbohydrate ONS for this individual so that it would ultimately lower the respiratory quotient and the production of carbon dioxide that is so taxing with this condition. On the other hand, you have diabetes. In this case, you're looking to minimize blood glucose spikes. So an ONS in this case might select fibers and other low glycemic carbohydrates to achieve that goal. And lactose intolerance is yet another example. And this one is a simple avoidance issue of a very particular type of carbohydrate, in this case, lactose. So you can build a product with any other carbohydrate system, but it would simply be the avoidance of this one for our lactose-free population. And finally, I want to talk about tube feeding, and in particular, sole source nutrition, where it becomes very important to maintain gut integrity and gut health. So many times it's important to add fiber or a soluble fiber to help achieve that goal, and in some cases mitigate or take care of persistent diarrhea. You can also have the converse, where you don't want the gut to be handling a lot of fiber in particular, and you would want to have a low residue product for that. So no fiber and more simply digested carbohydrates would be in order. And finally, tolerance is a big issue with tube feeding, and it's very important for compliance and for the health of the patient that they be able to consume the ONS for whatever metabolic symptom they're treating. In this case, you are factoring in the osmolality, and we know that carbohydrate type, carbohydrate amount, and the use of the emulsifiers and stabilizers, such as the carrageenans, can influence the osmolality of a product. So that's a very important consideration in the design of any ONS for any type of metabolic condition. So now that I've been through some of the basics to describe the taste and preference for sweetness and the role of carbohydrate in food and in physiology, I want to bring it together in a bigger picture of how a manufacturer of an oral nutrition supplement will take many considerations into play before we develop a product. First and foremost, particularly related to this nutrition facts panel and the revision of it, we need to take into account perception of the consumer. Who will be consuming this product? We know that adding the added sugar line on the nutrition facts panel can be confusing, might be confusing in the early stages of this, and so we want to make sure it's understood. And as health professionals, I think we can help clear up that confusion. And the main point here is that in all recipe and formula-based products, any source of sugar that's included will be considered added sugar. So that's an important distinction between other foods where it's inherent and would not be on the label. In this case, all will be considered added sugar, but they are selected very carefully for both their role in the ONS as well as their physiological role for the consumer using it. We also know from the perception standpoint that taste is king, and we know this. So it's important that we drive the preference, the liking, and the palatability of the product, and this will really drive compliance, particularly for those who are looking to manage a chronic condition. Then we take into account a lot of the food functionality issues, so reducing sugars and browning. Do we need to avoid those, to avoid off flavors? With viscosity, is it important that it be thinner or thicker? One example where you might want a more viscous product might be with that of dysphagia or swallowing problems. So we could use carbohydrates to make a more viscous product. Osmolality is also a very important consideration, especially when it comes to tube feedings. Osmolality is the driver, significantly so, of tolerance, especially when it comes through a tube feed. So in this case, you want it to be adjusted by carbohydrates, fibers, sugars to maintain a preferred and optimal osmolality so you don't end up with symptoms of intolerance, such as nausea, vomiting, diarrhea, cramping, or constipation. Also, the fiber and the fiber source would be important, as I've mentioned previously, as would glycemic control, so the selection of lower glycemic carbohydrates into a system. And finally, I want to end with supply chain. It's important when manufacturing these products that all the sources of carbohydrate are readily available. If there isn't enough in production, then it won't support the manufacture of a product. So a company always has to take into account what is available to them in order to make the products. So today we've reviewed the role and science of carbohydrates in oral nutrition supplements, and I hope that you found it helpful.
Participants briefly convened for a panel discussion to further examine other issues surrounding the updates to the nutrition facts label in relation to carbohydrates.
Well, we've covered a lot of information through about carbohydrates and about other nutrients, and so I want to dig a little deeper into the carbohydrate issue right now. So, Carrie, in thinking about the concept of added sugars, and that's getting a great deal of attention today, why are sugars added to different foods? And a lot of folks, I think it's pretty easy just to take out and remove the added sugars. But if you look at food science and you look at food technology, that's not always as easy as it may seem to be. Can you comment on why sugars might be added to food in addition to taste?
Yeah, absolutely. Sugars play a lot of roles in food through what we call the organoleptics and the hedonics. So they do the simplest thing, which is to add sweetness and flavor. They also play a technical role in food, so they can act as bulking agents. And this goes beyond sugars as well. This goes to other carbohydrates, but they provide texture or mouthfeel, so depending on the food, it can really drive that appeal. And then it can also impact things when we talk about an oral nutrition supplement, for example, where osmolality is very important for tolerance. You want to make sure that the carbohydrate system, being both added sugars or other carbohydrates, can meet the expectations for tolerance, meaning that it's a well-tolerated product. The more sugar, it might be adverse effect on the person's ability to tolerate. So it spans everything from palatability and preference to functionality and even treatment, if you will.
So to that point, Chris, maybe you can help us understand what's the difference between different types of sugars, whether it's naturally occurring versus added, or maybe whether it's honey versus raw sugar. Are there advantages to one or the other as it comes to metabolism and the body using those sources of sugar?
With a focus on natural products, we've tried to move towards, we see more honey, we see more agave nectar, we see all of this. And what it's really pointing down to is that chemical structure of what the sugar actually is. If it's a starch, it's a long branch chain source of carbohydrate that has to be digested down. For added sugars, whether it be honey, whether it be cane sugar, whether it be beet sugar, whatever that sugar source is, it's essentially been refined down to be the smaller, freely available carbohydrate, which is more easily absorbed. So they're all going to have a very similar kind of effect on the diet and on the body.
Certainly with the new addition on the label of the added sugar line and the daily value that no more than 10% of your calories should be coming from added sugar, how much attention should the consumer give to that added sugar line? Should that be the first thing that they look at?
You know what? I would say the first thing that they should look at is total calories. Again, this is a total picture. It will also be based on that person's lifestyle and preferences, and are they or are they not managing any kind of medical condition or not. Therefore, trying to target 10% is a general recommendation for generally healthy people. You will always have those where some more is fine, or those who will even target less. So I think it's a good guidance, but it can't be the one and only thing that should dictate food choices.
So some of the big changes that we've seen as it pertains to carbohydrates are, on the label I should say, are the fact that we have seen a decrease in the recommended amount, and so the daily value for carbohydrate has gone down. We've seen the increase in fiber recommendation, and so the daily value has gone up. And then we've seen the added sugar line with a new daily value for that. So as we're looking at that, Carrie, can you help us understand in totality what that means for carbohydrates? Where do they fit? How do they fit? How should we be using this information?
Sure. So we need to remember now that the FDA proposed and finalized this rule with the intent of giving people information to help them maintain healthy dietary patterns. That is the overall intent of the Nutrition Facts panel. So when you look at what's on there, it is supposed to be science or evidence-based, and that's what I think we're seeing in the reflection there. And it's also largely driven by the fact that we need to be very cognizant of caloric intake or total calories, right? So for individuals looking at the label, they'll see that fiber has increased because we have science that says fiber is good for you, whether it is improved digestion or laxation or feelings of satiety to help control food intake or cholesterol reduction. So it drives a benefit. So of course we would like to see it in people's diets. And the recommendation has gone up according to science. For carbohydrate and sugar, again, it's about making good choices for an overall dietary pattern. So in essence, keep your added sugars lower because those are essentially calories, right? Added sugar per se does not come with other nutrition. It delivers energy. So that's why the recommendation is to minimize or, maintain lower intakes of added sugar. Carbohydrate would fall into that same space, and therefore that's why you see it lowered as well. As an energy source, it's important. At all stages of our life cycle, energy is crucial, whether it's for exercise or, just focus and energy. So we don't want carbohydrate necessarily demonized. We want to make sure that there is diversity and variety in our dietary pattern to deliver the essential nutrition we need as well as the right level of energy. So that's why I think we've seen that reflected in the new Nutrition Fact panel rule, is to help us with those choices. And carbohydrate still has a very important role, but quality and quantity now are being differentiated, I think, by science and by the Nutrition Facts panel.
So Chris, we've covered a lot of information on in this discussion today. What are your key takeaways from the discussion?
I think with the changes in the food label, it gives a lot of information and some new information that has really emphasized areas that have become public health concerns. And I think it creates a resource for people to make more informed choices around the areas where we're trying to reduce saturated fat, we're trying to reduce added sugars, we're trying to increase fiber consumption. So the label gives us this information now to translate those messages into food choices.
Great, thank you.
Thank you for participating in this program, Decoding the New Nutrition Facts Label, Carbohydrates. We hope that this program will further your understanding of the mandated changes in nutrition labeling practices and support your effort to help you and your patients stay healthy and informed.